Good morning, students. In the today's session, we'll learn about data encryption standard algorithm. Now, we'll see what is a data encryption standard algorithm. It is a symmetric key block cipher that was used for secure data transmission as well as for the storage. This data encryption standard will be worked on a fixed size blocks of data, and it is going to use a secret key for both encryption as well as for the decryption. Here, whenever we are working with this data encryption standard algorithm, it is a symmetric key block cipher that was widely used for securing of the data transmission. Now here, we'll see what are the other next steps which we'll see with this. Now here we have a step-by-step procedure which is going to the explanation for the data encryption standard algorithm. First, how we are going to generate a key. The first step for the generation of a key is like the first step. We have to generate the 16 subkeys from the original 56-bit secret key. Whenever we are generating a subkey, we are going to generate the subkeys which are derived through a process of key scheduling. Now here, if we take this 56 key, it goes under the permutation and it was divided into two 28-bit values, okay, which are subjected to circular shifts. This process is repeated around to produce a 16 subkeys. Now, here we are going to learn what is the initial permutation. Here, the initial permutation is first we have to take the 64-bit plain text, undergoes an initial permutation, and we are going to rearrange the bits on a predefined permutation table. This permutation table is done as an initial mixing of data. Next, in the next step, we are going to do the data splitting. What is meant by this data splitting? Data splitting means here the permitted 64-bit data block is then split into two 32-bit halves. Okay, one is as a left and another one as a right. Now, next, what we have to do the encryption for 16 rounds of encryption we have to perform. This data encryption algorithm, whenever if we are working with this, we are going to operate through 16 rounds of encryption, and each and every round is involved with a combination of permutation as well as the substitution. Then we have the key mixing operations. Okay, the Fistel network structure is employed in each and every round. Here we have a high level overview of each and every step, how we are going to follow. Okay, and here whenever we are working with this data encryption standard algorithm, we have to, this is a step-by-step procedure for the generation of the algorithm. And here in the 16 rounds of encryption, the step-by-step we'll see. The first one is the first E-box expansion. First, we are going to take the 32-bit R half. It's expanded to 48 bits. Here, as I already told in the previous slide, here it is going to divide into two parts. One is a left as well as the another one is a right. Okay. And next here, like the half, the left and right, we are going to divide that into the 32-bit R half is expanded to the 48-bit using the E-box. Okay. And next we have a key mixing. The key mixing will be done the XOR with the subkey. Here, the expanded R half is XORed with the current rounds of the 48 subkeys. Then we have to, first I told we have to do the substitution, then permutation. What is the substitution? The XOR result, whatever we are getting the XOR result, which is divided into 8 6-bit blocks. Okay, and each block is substituted through S blocks, and each mapping is with 16 bits to 4 bits. Okay, and then we have to perform the permutation box. In the permutation, this 32-bit output from the X box undergoes a permutation using the P box, and then we have done with the right part R. Now we have to do the same with the left. The permitted output is XORed with the original left half. Okay, and after this round, the left half becomes the right half, and the right half becomes the left half. Okay, this is the XOR process. Okay, and next here, what is our final permutation? In the final permutation, after completing the 16 bits, the L16 as well as the R16 halves are combined, and the final permutation is applied. And this is the inverse of the initial permutation. And what is output we are getting here with this data encryption standard algorithm, we are going to get the final 64-bit block in the encrypted ciphertext. And next, what we have here, we'll see what is meant by decryption. Now we have done with what is encryption. What is meant by decryption? This decryption is a DES, especially this decryption means decryption standard algorithm. This is essentially the here this decryption is also comes under this data encryption standard algorithm is essentially the same process as encryption, but the keys are used in the reverse order. Whenever if we are working with encryption, we are going to use some keys. All those keys, whatever steps we are following, all those steps we are going to follow in the reverse order. Okay, and the ciphertext undergoes the initial permutation, which is followed by the 16 rounds of decryption using the subkeys in the reverse order. And the final permutation is going to produce the output plaintext. And it's important to note that this decryption, this data encryption standard algorithm, it is historically significant and no longer considered secure due to its short key length. Because we are going to use the very short key length, that is the reason it is not fully secured. Okay, and to overcome this problem, the advanced encryption standard has largely replaced this data encryption standard for secure cryptography applications. Now here in this data encryption, what are the levels of the data encryption? The same what we have done till now, but the same I am going to explain. Here first we have to take the 16-bit plain text, and the 16-bit plain text is divided into two 32-bit text. One is a left 32-bit text, another one is a right 32-bit text. This left 32-bit text we are going to name it as L, and the right 32-bit text we are going to name it as the R. And next, by implementing the 16 rounds, with the 16 rounds, we are going to generate one key. Okay, this is a final permutation. The same will be applied in the reverse order to this R. And finally, we are going to combine this L with R. Okay, and next we are going to perform the XOR operation. And finally, we are going to get this 16-bit ciphertext. By following these above steps, we are going to generate the ciphertext. But when compared to other algorithms, to whatever problems we have, this data encryption standard algorithm, it will be solved with the advanced encryption standard algorithm. Here in this, like here, like with the above steps we have done with the ciphertext has been generated. That means the key has been generated for performing both the encryption as well as the decryption. In this, we have learned about the decryption also. This decryption in the DES is essentially the same process as encryption. But here, whatever the subkeys we are using, all those we have done with the reverse order. Finally, what we have learned from this DES is we have the advanced encryption standard. It was largely replaced the data encryption standard for secure cryptographic applications. Thank you. See you in the next session.